You are watching the Target 8.2 retest video. In this video, we're going to solve equations, absolute value equations. We're also going to show you how to solve them using graphing technology too. So make sure you have your white packet with you. You need to finish this packet in order to retest. Any questions that you have in addition to this movie, feel free and ask your teacher before or after school. Here we go. We're going to do number 3 and number 6 on that front page, but first let's write down a couple little notes here. They deal with the absolute value. So remember now, the absolute value is just the distance from 0. So if we think of this and we're given an equation, a real simple equation that looks like this, absolute value is equal to 4. We look at a number line, here's 0. And I drew the number line out to 5, and we're looking for the distance from 0 equal to 4. So we can go this way on the number line, 1, 2, 3, 4, and we get up to the number 4. Or 4 the other way, that takes us to negative 4. So we get actually two answers that are 4 away from 0. We get 4 and negative 4. So x equals 4 and x equals negative 4. So we're going to use that idea to solve these absolute value equations too. So the first step that we're going to use, first thing we're going to do is we're going to isolate the absolute value. And once you do that, you have to remember that there's a positive and a negative answer, and we're going to solve both. Okay, so if we look at number 3 then, in order to isolate the absolute value, we have to get rid of this and this. And PEMDAS backwards, whenever you solve, you have to take care of the stuff that's not touching the absolute value first. Those things are the multiplication pieces, the ones that are touching. So we want this one gone first, and we'll add 1 to both sides. Adding 1 to the right side, we get negative 16. And then we'll divide both sides by negative 8. And now we have absolute value isolated. So what's next then? Now remember, we have two answers. So we have negative x minus 7. Whatever's inside there is equal to the 2 that you see, but we also have negative x minus 7 is equal to negative 2. We have to take into account the positive distance, but we also have to take into account the negative distance, both directions. So then we solve each one, and they should be easy stuff that you did in 8th grade when you solve linear equations. We add 7 to both sides, usually 2 steps here, and then divide by negative 1. We get 1 answer. And you're going to find you do the same steps on the other one, but the answers do end up being different. Divided by negative 1. So we have 2 answers, negative 9 and negative 5. All right, now notice in the second one, number 6, 4 is out in front. It's kind of just like the negative 1. It's added. Negative 4 is added to the absolute value here. And then this negative 4 is multiplied. So we want to take care of that, adding a positive 4 first. You end up with 4, absolute value 2x minus 4 equals 40. And then we'll divide by 4. And therefore we isolated the absolute value, step 1. Okay, next comes the positive and the negative piece of that. So we have the positive distance, but we also have the negative distance. Okay, and then solving both. So we'll add 4, divide by 2, and again we'll add 4, but this time adding 4 to negative 10 is different than adding 4 to positive 10. I can't say that enough. That's usually where we go wrong. And we get both of those answers. Okay, so on all of these problems, you're going to isolate the absolute value. You're going to remember that both positive distance and the negative distance, and you have to solve both of those equations to get your answer. All right. So then it comes to graphing technology. So use graphing technology to solve the following absolute value equations. Now this is true with any equation that you see, any form, anything. If you plug both sides into the graphing calculator and see where they intersect, those are your solutions. So in this case, you have the left-hand side, that's 4, but you also have this right-hand side, which is an absolute value. So we're going to graph these two equations. We're going to graph y equals 4. We're also going to graph y equals 2 times the absolute value of x plus 3 minus 4. So on your graphing calculator, graph y equals 4. And then hit tab and get a new line for another equation, and that's y equals 2 times absolute value of x plus 3 minus 4. If you graph the left-hand side, the y equals 4, you get a straight line through y equals 4. If you graph the other equation, the absolute value equation, see, I'll graph it by hand, but you would see it starts at -3, -4. It goes up 2 and over 1 for each one of these. And to the left 2, because it's an absolute value, they both go up in this case. So here's one of the legs, there's the other one, and we see that it would intersect in this place and this place. Now we're interested in the x values of those places. This is 1 comma 4, that point, and this point is -7 comma 4. So x must be equal to -7, and x must be equal to 1. So there you have it. You graph both of them. I graphed them by hand. You probably could too, but it's probably easier to use the intersect key and graph them using the calculator and then seeing where they intersect there. And there's a few more problems like this. Sketch what you did on your graphing calculator onto your worksheet so we know that you know how to do it. Rewind the video and watch this part again, or else go see your teacher before or after school. One hint, if you don't have a graphing calculator at home, this thing is awesome. You don't need to hit the intersect button at all. You can just graph both of them on your computer and then just run your mouse over the intersection points and it'll tell you exactly what these points are. Alright,